So next let's look at part B here. Here we want to be integrating x cubed times ln x dx. Now one tricky thing with integration by parts is that you won't always be told that you need to integrate by parts. Sometimes you need to just look at an integral and decide what technique you should be using. So in this case, if I just gave you this integral without any other instructions, we could still see that we needed to use something like integration by parts because we don't know how to integrate products like this one, this x cubed times ln x. So we don't know how to take an antiderivative of that right away, but what we do notice is that this integral does have a factor that would be made a lot nicer if we could differentiate it, namely that ln x. So we don't like ln x, but we do like its derivative. So a good choice for u here would be this ln x, and that means that the rest of the factors in this integrand are going to be dv. So here we're going to get u as ln x, and that means that du would be 1 over x dx. And the rest of the stuff past the integral sign has to be dv. So anything that you don't choose as u will become part of dv. And this would be x cubed dx. And if dv is x cubed dx, then that means we can get v by integrating x cubed. The integral of x cubed would be x to the 4th over 4. You can choose, as v, you can choose any antiderivative that you want. So I could choose v to be x to the 4th plus 7. So, well, x to the 4th over 4 plus 7. Because then if I differentiated this, I would get this dv down here. So this would be a valid choice for v, but ordinarily we just use the simplest one. So I would say that v is x to the 4th over 4. So that's our choice of u, v, du, and dv. And now remember the integration by parts formula says that the integral of u dv is equal to uv minus the integral of v du. So we're going to apply that formula here. Remember that the integral that we started with is the integral of u dv. So this should be replaced with u times v. So that would be ln x, which is u, times v, which is x to the 4th over 4, minus the integral of v du. So this would be the integral of v, which was x to the 4th over 4, times du, which is 1 over x dx. And now we can simplify this a little. So the original integral that we wanted to compute is this, minus the integral of, here I can cancel a factor of x from the numerator and denominator. So this would become an x cubed over 4 dx. And if you'd like, you can factor out the 1/4 from the integral here. You don't have to. But if you don't like dealing with fractions inside of that integral, then you can factor out the 1/4 first, or you can just remember that that 1/4 is along for the ride. So you can keep that 1/4 as a factor whenever you do this integral. But either way, you should end up integrating this x cubed. And we know that the integral of x cubed is x to the 4th over 4. So this would be minus 1/4 of x to the 4th over 4. And because we just did an antiderivative, we need to add a c. So altogether, this ends up being ln x times x to the 4th divided by 4 minus x to the 4th over 16, if we just multiply the numerator and denominator here in this fraction, plus a c. And that's the integral that we're looking for. And you can check if you take the derivative of this that you do get x cubed times ln x. Okay, so integration by parts it's a complex formula, but it's nice because it allows you to exchange the integral that you started with for some hopefully easier integral, and still allows you to compute the antiderivative that you want. So before this, we didn't have any techniques that would allow us to compute the integral of x cubed times ln x, but now we do. Okay, so for this last example, example 3, we're just going to go through as many examples as we can squeeze in here of integrating by parts. And I think this would maybe be a good example for you to try on your own. So if you want to, before you start the next video, you can try doing a few of these examples just to try to ingrain the use of that formula. I'll go ahead and copy the formula down here. So we have the integral of u dv is equal to uv minus the integral of v du. And again, I think the main thing here is just being able to select the correct value for u. Once you choose u, the rest of it, there's still a lot to do, but the rest of it is relatively easier, I think. So we'll get started on example 3 in our next video.